and welcome to another Unity 5 tutorial. In this tutorial I'm going to show you how to procedurally paint textures onto a terrain. But before we start that, I just want to explain how the process works and what's going on underneath the textures. So I've got these two planes, and one has a dirt texture on it and one has a grass texture on it. Now, what happens when you paint textures onto a terrain is that you get a certain amount of one and then a certain amount of another one. So they're overlapping, and the paintbrush tool in the terrain section in Unity allows you to paint them on at sort of different opacities. Now, if we apply an opacity to, say, this material on this grass, which we can do by changing the color that's on it and going to this alpha and sliding this down, it gives us a final image when we look through both of them that's a blending of, maybe half of the grass texture and all of the dirt texture. And this is what happens when two textures overlap on a terrain. Now, the alpha value in the case of flat planes like this and a single material is applied across the entire surface. So the alpha value that I set for here, let's say it's 50%, transparency, then it's 50% for every single vertex on this plane. Now, with a terrain, you can actually save the alpha values on each vertex of the terrain and have them to be different. And these mappings are called splat maps. And in Unity, they're also called alpha maps because they're setting the different alpha values across the entire terrain. So just to illustrate this, I want to go back to Photoshop and show you something. So in Photoshop here, I've got three layers. I've got a green layer, a brown layer, and a yellow layer. Now let's say that these represent the different types of terrain, like grass, dirt, and sand, for example. And we're going to put, say, grass on top of the mountains and the dirt in the middle and the sand on the bottom. But each texture is like a blanket that's been put over the terrain. And so you get these three layers sitting on top of the terrain. And therefore, we have to create the splat maps which say which texture shows at which time and how much of that texture, so it will blend together. Now I've got some masks on these textures here so I can illustrate that. When you've got your splat map fully white, it means it's going to show that entire texture. So because green is on the top, we're getting all of it. Now if I get a black paintbrush, and I'll just turn that up a little bit and put it on 100% opacity, and then draw inside of this particular splat map here, you can see that wherever the black is, there's no green, but it shows through to the next layer. So it's blending this layer in with none of the green at that point. But if I put this opacity at, say, around 50% and then draw it, I get a different color because I'm getting 50% of the green and then all of the brown that's underneath that. Now I can also draw on this brown layer through here. Now it's not going to affect anything where the green is because the green's on top of it and the green is at full opacity just there. But here, for example, if I rub this out along where I was allowing the brown to show through the green, I'm now removing the brown on the brown layer from its splat map and letting this yellow show through. So each of these masks here is essentially, it's a splat map. And so let's say for a mountain we have, there's a mountain over here. Okay, so the green is on top of the mountain and we're slowly revealing as we go down the mountain. We might want different opacities showing the dirt, and then once we get right down low at the bottom level of the mountain, then we're going to get rid of some of the brown and bring in the sand at there. So this is looking from a top-down view of draping these things over the terrain and rubbing bits and pieces out of those using these different splat maps. Right, so I hope that made some sense to you, but that's exactly what we're going to do now, but with code. All right, so let's remove these planes because we're not going to be using those, and let's add a terrain. So right click in the hierarchy and let's go 3D object terrain, and that will create a terrain for us. Now this terrain we want to sculpt to different heights, and we're going to use the height values in the terrain to automatically set where the different textures are going to appear. So I'm going to grab hold of a largish paintbrush and just start painting on this terrain, just to make something that's a little bit interesting, something with a bit of height at different heights, because I want something that's got snow right on the top of it. It's not going to be pretty, but it's going to work. Okay, let's make this mountain really high and some lower bits in here. All right, so here's our terrain. Okay, and I've got some textures that I've loaded in that I'm going to put on there. So I've got a dirt texture, a grass texture, a rock, a sand, and a snow. Okay, so I want to add those textures to the paintbrush tool that's in the terrain in order from lowest to highest of where I want to use them. Right, so the bottom layer is going to be sand. So let's click on Edit Textures, Add Texture, and I'm going to drag the sand over to here. Now, this will automatically add it across the whole map. Don't worry about that because the code will fix that up later. Now, at this point, you'll see the tiling effect that's going on in that particular texture. If we edit texture and just edit that particular one, you can change the size of those tiles in this bit. So that's now at 15 by 15. We could change it to 50 by 50. And now you can see that the tiles are spread out more. 100 by 100 gives you a much closer in. You can actually see footprints in that, so that'd be a bit unrealistic if it was that large, but anyway, let's leave it like that. Well, I'm just going to put them in. You can change these later on after you've added them anyway. Right, so let's add the next texture, which will be dirt, followed by grass, followed by rock, followed by snow. Okay, so there's our 5 different textures. Now what we're going to do is write some code that creates the splat maps for each of these based on the height, so that in these lower lying areas around here, it's going to be like full opacity for your sand and nothing of the other colors, just the sand. And then at the next level, it'll be dirt, and the next level will be grass, like that. So create yourself a C# file called paint terrain. Okay, so what is in this file? So the class is called paint terrain, the same as our file. We've got the usual libraries at the top that come in. Now the first part of it is a public class inside of the other class, and in that we're going to store the index of the texture that we're using and the height at which that texture starts. So the sand, for example, is texture 0, and it's starting from height 0. Then the next texture, which is dirt, would be texture index 1, and its starting height might be 15. Okay, so we go through all of our textures and we'll add those in using this class, which then ends up in this array here called splat heights. And this splat heights basically stores all of those alpha values that need to be stored about how much of that texture is going to show through at that point. Now you might have noticed up the top before our class we've got this system.serializable. Now this makes splat heights exposed and visible in the inspector. And if you haven't used this before, you might be surprised what we see, and I'll show you that when we get to setting the values for it. Okay, so all that's in this folder file is a start function. The start function creates all of the splat maps and stores them with the terrain and the textures that are with the terrain. Now, once you've run this once, even when you stop playing in the editor, the splat maps will be set. So they permanently get set, and at that point you can get rid of this script if you're happy with the way your terrain looks. So you don't need to run this all the time or with your game code. You only run it as you need it. So let's go through this start function. So first of all, we grab hold of the data about the terrain, which is to get hold of all of the heights in it. And there's a structure in Unity called terrain data that has all of these things in there. So to set our variable terrain data, it's terrain.activeterrain.terrain data, which will get us an array or matrix, I guess, of all of the height values. Okay, so for at a particular XY on this height map, terrain, it will get us the height. Okay, next we're going to make another array or matrix, so it's three dimensional, and it's going to be the width and height of the terrain, and it's going to be the number of layers. So this is the number of textures, and it's their splat maps that are in here. So to start with, you've already got all of the textures that you added into here. So they're already loaded in. They already have splat maps, but the splat maps, like for this, is full on everywhere, and the ones for this is to be shown nowhere at this time. So we're grabbing hold of that matrix to get our existing splat maps. Right. Next, we're going to loop through the height and the width of the terrain, so one vertex at a time, using the height and width values that are given to us in our terrain data. We're then going to find out what the height is at any particular point. Now, we do this with the getHeight function called on the terrain data. Now, what you'll notice here is instead of getting it at XY, it's getting it at YX. In previous versions of Unity, you could use XY and you would get the height at a certain position that lined up with the splat maps. But in the latest version of Unity, and I don't know why this is, but the splat maps are like the inverse of the terrain. So you have to actually use Y and X just for this little bit. Otherwise, your images that you see on top of your terrain don't line up with the heights. It's quite odd, actually. I don't know why it's like that. If anyone does know why, please do enlighten me. Now, next we've got a splat array of float values. Now, this is a vector of all of the different alpha values for each of those different textures. So there's 5 textures, which means there will be a float array of 5 values, where the first value is how much alpha is in the first texture. The second value is how much alpha is in the second texture. The third is in the third texture, etc., for the length of those maps. So that makes this code a little extendable as far as you can have as many textures as you like already added in and then add those heights onto the terrain. Okay, next we're going to loop through all of the height values that we've put into, let's go up here, into this array. Okay, because we're putting in the texture and the height at which that texture starts to appear on the map. And we're looping around and we're saying if the terrain height of the actual terrain is greater than or equal to the starting height for a particular texture, then we want to set that value to full opacity 1 for that texture in that splat array. So it will be fully turned on. And for all the others, they'll be fully turned off. Now, after we've done that, we then loop through all of those splat values in that single list of floats for that one particular place on that terrain and we set those values into the splat map data at that X and Y. So it's X and Y, and then there's at position J is all of these splat values for each texture. Now, once that loop has gone around and finished going through the whole terrain, we now have splat map data. Remember, it was the one that got the existing data for splat maps out of terrain. And we've now updated it with our values, and we're going to put it back into the terrain data, which is the underlying structure beneath our terrain, and we're setting the alpha maps to that. Okay, so that's all you need, just that start function. Right, so save that, switch back to Unity. Now you want to get that code and attach it to the terrain. When you do, you'll now see that you've got splat heights has been exposed. And this is the array where we're going to say, want this texture at this height, this texture at this height, this texture at this height. So we're going to have 5 of them. Now, remember we put that system.serializable above the little class, which is here. What that does is it exposes these values here in the inspector so that we can set them, and if you name them correctly, you then know what you're talking about back in the inspector with the code. So here you can see that element 1 needs a texture index and a starting height. So we want the sand to start at 0. So that's fine. We want the dirt, which is index 1. We want that to start at, 15. And the next one, which is the grass, which is index 2. I want that to start at 15, what do you reckon, 30. And then the dirt, which is 3 at, let's say 60. And then the snow, which is 4 at, what do you reckon, 100? Okay. You can always change these later anyway. Now, when we run this, let's see what happens. Right, bang, there we go. There's our textures on our terrain, and it has put them on by height using those splat maps. So if we just go down here and have a little closer look, you can see that the textures are now changing from sand to dirt to grass, and then if we go over to the mountain, you can then see also where you've got the rock and the snow on top. Now, something that will also be obvious to you is that you've got the sand on the bottom, and then you've got the dirt as well, but notice that you've got a part of the sand still showing through. Okay, because the height for the sand is set to 1 anywhere above 0 all the way up. It's not just being set from here to where the dirt starts, so it adds it for the whole lot. If you want to stop the sand where the dirt starts, then you need to add a little bit more code. So we can open up the paint terrain script again and have a look at where we're setting these heights here. So this is the if statement that tests if the terrain height is greater than a particular value, then it's going to set that splat. So the other thing we want to do is test if it's greater than a value, but it's also less than the value of the next texture. So if it's greater than that and the terrain height is less than, I'm going to say equal to as well, so we get a little tiny bit of an overlap of the two textures. And we want this whole bit here for I plus 1. Now, the issue here is that at I plus 1, when we get to the end of the string, is that there won't actually be an I plus 1. So I might have to put another test in there. So I'm just going to put in here if I is equal to splat heights dot length minus 1, which would make it the very last texture in our list, then splat I will equal 1. Else we can test for that, because if we're looking at the very last texture on the list, there's no height value to test it for. Actually, this still needs to have a test in it for the height as well. So if it's the last texture and it's at the correct height, then set it to 1. Otherwise, then make sure it's between the texture and the next texture that's in the list. So we'll save that and go back to Unity, and let's just run it. Okay, so now you can see what's happened. It's very different than what we had before. The sand that was continuing all the way up is now not. In fact, they were all continuing all the way up from their own particular height that they started at. But now we're actually cutting them off very, very tightly. You can see that they're finishing. And I've got that slight little tiny overlap with the less than equals or the greater than equals, so that they do give you a little bit of a fuzz around the edge, and you can just kind of see that there. Okay, so that's how you color the terrain in. If you were to make this terrain using a Perlin noise, such as we've used in the other infinite terrain and procedural generated terrain ones, you could then run this code afterwards in order to automatically texture your whole terrain. Right, so in the next tutorial, following on from this one, I'll have a look at blending these borders of these colors in a little bit better for you. Great, well, hope you learned something and enjoyed the tutorial, and I will talk to you next time.